Hi and welcome to this video where I'll show you how to calculate the expected return and standard deviation of an N asset portfolio in Excel. In this video I'll show you both the manual way as well as a quick Excel shortcut you can use to calculate these figures instantly. In our example, our portfolio consists of 5 stocks where each has their own expected return as well as the proportion of our money that we're investing in each stock, in other words, the weight. On the other side, we have the variance covariance matrix for the stocks in our portfolio. Here, the diagonal cells highlighted grey contain the variance of each asset, while the other terms correspond to the covariance between assets. For example, 4% is the covariance of assets A and B. We'll need to use this matrix to calculate the portfolio's standard deviation. At the bottom, we have the formulae that are used to calculate the expected return and the standard deviation of a 5-asset portfolio. We'll use these formulae to calculate the outputs manually and equally to prove that the shortcuts that we're going to use are accurate. Let's get started by calculating the expected return manually. As you can see, the expected return is calculated by taking the weight of stock A, multiplying this by its return, then taking the weight of stock B and multiplying it by its return, and so on for all stocks in our portfolio. To start, we type equals. We then take the weight of A and multiply this by the return of A. We then take the weight of B and multiply this by the return of B. Take the weight of C and multiply this by the return of C, and so on for stocks D and E. This gives us 5.66%, which is the expected return of our portfolio. Now, this was quite a time-consuming process, and we only had 5 stocks. Imagine how difficult it would be if we had 20 or 30. The quicker and easier way of calculating the expected return is by using the SUMPRODUCT function, which returns the sum of products of 2 arrays of data. We type equals SUMPRODUCT. We first select the first array, which contains the return figures, followed by a comma, and then select the second array, which contains the weights. We can then close brackets and click enter. As you can see, this returns exactly the same figure. Therefore, this is a great shortcut for calculating the expected return for any amount of stocks. Next, let's move on to the risk, which is slightly trickier. To calculate the standard deviation manually, we're going to use this formula at the bottom. Since this formula is very long, we're going to decompose it. The formula consists of 15 terms, so we're going to calculate each term and then add them all up and find the square root of the answer to calculate the standard deviation manually. The first 5 terms are calculated by taking the weight of each asset squared and multiplying this by each asset's variance. For term 1, we take 17%, which is the weight of A, to the power of 2, and then multiply this by 5%, which is stock A's variance. For B, we take the weight of B squared, and then we multiply this by its variance, which is 4.7%. Next, we take 12% squared, which is the weight of C, and then multiply this by the variance of C, and then we can do the same for stocks D and E. the last 10 terms require us to take 2 and multiply this by the weight of one asset, followed by the weight of the other asset, and then multiply this by the covariance of both assets. We have to do this for all assets until we've included all combinations of variances. So for term number 6, this is 2 times 17%, which is the weight of A, multiplied by 31%, which is the weight of B, and then finally we multiply this by the covariance of A and B, which is 4% as per our matrix. We can then do the same for term 7, so this is 2 multiplied by 17%, which is the weight in A, multiplied by 12%, which is the weight in C, and then we multiply the covariance of A and C, which is 4.21%. I'm now going to calculate the results for the remaining terms. Now that we have the values for each term, we can find the portfolio standard deviation manually. First, let's calculate the variance by adding all of these terms. To calculate the standard deviation, we simply have to find the square root of this calculation as per the formula. Therefore, the standard deviation of the portfolio is 22.1%. As you've noticed, this is not only time-consuming, but also a very error-prone process, and we're only accounting for 5 stocks in our portfolio. Let's now consider a much easier and more efficient way. To do this, we're going to use the SUMPRODUCT function and the MMULT function, which returns the matrix products of 2 arrays. First, we type equals SUMPRODUCT, open brackets, and for our first array, we're going to select the weight of our assets. For the second array, we'll use the MMULT function, first selecting our matrix as the array, followed by the weights. We can then close brackets and click enter. Writing the function in this way has the same impact as calculating the variance using the formula. To calculate the standard deviation, we simply have to type the square root function in front of our formula and then click enter. This gives us 22.1%, which is exactly the same as the standard deviation calculated manually. So that's how you can calculate the expected return and standard deviation of a 5-asset portfolio in Excel. If you have more assets, let's say you have 20 stocks instead of 5, all you need to do is adjust the arrays that you're selecting while using these functions. What we've covered today is therefore extremely powerful because it can be applied to an infinite number of assets, saving you a lot of time trying to calculate it manually. This brings us to the end of this video. Please give it a thumbs up if you found it useful, and subscribe to the Excel Hub for weekly Excel tutorials, techniques, and examples.